So in this problem, again, we are going to apply law of conservation of energy. Maybe the heat this time is not going to come from usual sources like the heater or anything, but the principle remains the same, right? So it says a car of mass 1360 kilogram descends from a hill of 86-meter height, right? So it is descending with a constant speed, which means there is no change in kinetic energy, right? Assuming that all the gravitational potential energy of the lost by the car goes into hitting the brakes, right? So brakes are going to be heated, right? So brakes are going to receive Q from the loss of gravitational potential energy, okay? Estimate the rise in temperature of the brakes. It takes 16 kilojoule of energy to increase the temperature of the brake by 1 Kelvin, okay? So 16,000 joules or 16 kilojoules is required to increase the temperature by 1 Kelvin, right? So first find out how much energy the brakes will receive, and we are going to simply divide that with 16,000 joules to find at what temperature what will the rise in the temperature of the brakes, okay? So clearly we know from the law of conservation of energy and gravitational potential energy is simply going to be mgh, right? So loss in the gravitational potential is going to be mgh. Let's find that out. M is 1360 kilogram, right? G is 9.8, and the height through which it descends is already given, 86 meters. So 86 meters, right? So that is going to be our energy which the brake will receive, which happens to be 1146 kilojoules, right? Or 1146,000, right? And 1 Kelvin temperature increase is equal to 16 kilojoules. So the rise in temperature is simply going to be the division of this. 1146 kilojoules is there, and it requires 16 kilojoules per Kelvin, right? So this is going to be 1146 by 16, and that is going to be 72 degree, not degree, 72 Kelvin, right? Or we can say the temperature will rise by 72 degree Celsius. And that will be our answer. So it's simply a matter of dividing that and again applying energy conservation law. It's pretty easy and simple problem.